Hi everyone, I'm Trevor with North Valley Search and Rescue. Today we're going to explore another video in our rope rescue series. As always, this video is for use in conjunction with professional training for North Valley Search and Rescue within the scope of our SOPs utilizing our equipment. This video is not a comprehensive training package, but rather a small component of training and should be used under the guidance of a qualified professional trainer. There are many methodologies and avenues to achieve a desired outcome, but paired or performed incorrectly can result in injury or death. All ratings discussed are with new, fully rated equipment under perfect conditions, which never happens. Used equipment, time, UV exposure, use, application, or any other condition or alteration will change the load capacity. All ratings discussed are approximations and are simplified for your basic understanding purposes only, not to calculate the actual loads or forces. We are glad that you're here with us today, and for a quick reference back to this video and others of ours, please click on the red subscribe button below, or just below that, the add to button and create your own playlist. Might I suggest naming one SAR. So let's kick into today's video. In this video, we're going to look at anchors. Anchors are some sort of object that we're going to set up to affix a component of our rope system to withstand the forces of the rope system. So therefore, if I have a load, I need it to be able to not move when I start pulling on that load or lowering that load. We have three different categories of anchors that we utilize out in search and rescue. The first one is natural anchors. Those would be something like a tree or a rock that we commonly see while we're out in the woods that we would wrap around. They need to be able to withstand all of the load forces that we're going to see from our load, plus a reserve so that they don't break or move. The next one might be a structure, and some sort of structure would be like a utility pole, a guardrail, or maybe a truck that we parked alongside. Those are going to be ones that we commonly see and use when we have an embankment off the side of the road that we need to go retrieve somebody off of or down at the bottom of a grade. The third would be artificially inserted anchors, and those can be different categories. We have what we call pickets, which we actually don't have here at NVSAR currently, but they're metal rods that are driven into the earth at an angle, tied together, and then the load is pulled at an opposing direction to them. We have ice anchors, which if you are not trained and qualified to use these, please don't use these as anchors. But these go into ice and they screw into the ice, and then we can connect and pull at a 90 degree to the pin. I also have some rock protection, which we might see if we go out and we're trying to retrieve a climber who possibly is at the bottom of a rock cliff. They might have some gear out there, some cams or some nuts, but we don't have these with North Valley Search and Rescue, and we don't employ them except for in rare cases where a trained and qualified safety officer would tell you otherwise. So those are the different types. And what we do with these is set them up so that we can, again, attach some component of our system to. So let's go ahead and start looking at, since I have a truck here, we're going to utilize a truck, in particular this B-post, because it's convenient and it's here, not necessarily because it's what I would use during a rescue, but we're going to start off with a tensionless hitch here on this B-post. So I'm going to take this and I'm going to wrap this around a minimum of 4 times around my anchor, which is going to use friction to not allow the rope to slip. The beautiful thing about this particular anchor is that even though there is a knot tied in the rope, it does not lose any of its rating because this knot is not tensioned. So this rope is a 40 kilonewton rope, and what I'm going to do is take carabiner, clip it here, and I'm going to snug this up just a little bit. We're making sure that these strands don't overlap. And you'll notice that this strand pulls on the anchor and uses friction on each of these, and this is still loose. With that being loose, there's no tension here on the knot, and therefore we haven't reduced our load capacity of the rope. So this is a tensionless hitch. It gets wrapped around at least 4 times. You can go more. The downside to this is, one, the end of your rope is now tied up and utilized, so you can't utilize it for anything else. Two is that if this is a larger tree or larger rock and you wrapped it around, now you've lost a bunch of rope tied up into the anchor instead of using something like webbing. So you have to be rope rich. You have to know that you're not going to utilize all of your rope and that you're not going to need this other end. Now we're going to look at another way to utilize rope to go around an anchor post where maybe we're not rope rich, so we don't have enough rope to go around a really, really large anchor, being a tree or a rock, 4 or 5 times, but I don't have any webbing sitting around and I still need to be able to tie an anchor. So I've got this rope which is rated and it's really nice, so I'm going to go ahead and use it. So what I'm going to do for this particular one, I'm going to go ahead and take 2 stretches of this, because I know for this particular size anchor that I want about 12 feet of rope, and for me each span is 6 feet. So I'm going to take the end and I'm going to wrap it around this post or my anchor, and I'm going to pull this together and make sure that realistically I'm between less than 90 degrees, ideally somewhere around 60 degrees. I'm going to go ahead and now do a retrace of this figure 8. So I've got a retraced figure 8. And once I have this retraced figure 8 done, you'll notice that I still have a significant amount of tail. And here's what I'm going to do with that tail. So I'm going to go ahead then and I'm going to do a figure 8 on a bite on the tail end, making sure that I have at least 4 inches of tail sticking out. Okay, so now here's what I've got. I've got a rope that goes down to my bag that I can utilize for my haul system, my lower and haul system. It goes through, around my anchor, whatever that may be, and through a figure 8, which was a retraced figure 8, and I've got 2, 4, 6, 8, 10 with long enough tail. And then I also have this, what I'm going to call a stinger, coming out the end with a figure 8 on a bite, 2, 4, 6, 8, 10 strands, and I've got a long enough tail. So now I would be able to take a carabiner, clip it in, and use this to connect my descent control device or whatever else I needed to connect to this, and I can take this rope and go ahead and use it to run down to my load, wherever that is. Okay, so this is a 40 kilonewton rope, and because I've tied a knot, it doesn't matter whichever one is most limiting, but they're both figure 8, so it reduces it by my load capacity by 25-ish%. So we're down to about 30 kilonewtons for this particular setup. Some of the considerations that I have, again, one is that this needs to be less than 90 degrees. 2 is that now I'm stuck with this end of the rope tied up into the system and I can't get away from that, which is, you know, pros and cons to it. And I have this end over here, which then means that I have a whole bunch of slack. So if I have all of my rope in a bag here, I'm going to have to pull all of that rope out to access the other end of my rope to be able to set up my lower and my haul. Now we're going to look at how to tie a wrap 2 pull 1. For wrap 2 pull 1, we're going to use 1-inch tubular webbing, which when it's new rated at about 18 kilonewtons. So what I'm going to do is I'm going to go ahead and tie an overhand knot here to facilitate tying a water knot in just a moment. And what I'm going to do is take this, pass it around my anchor, and just let that dangle on the front side. And I'm going to wrap around a second time. So now I have 2 full loops that go around my anchor post. I'm going to go ahead and finish off a water knot. If you need a review on water knots, then you can go ahead and go to the video that's linked in the description below, which will take you to how to tie an overhand and a water knot. Okay, so I've got these all set up. I've inspected this, that there's enough tail on each side and that the knot sits flat. And with a wrap 2, pull 1, again, there's 2 wraps around this, I'm going to take the strand that does not have a knot in it, and I'm going to pull that away from the anchor post. Then I'm going to put the knot, orient the knot so that it is on the front side, so it has the least amount of pull on it because there's friction going around each of the sides. And I can simply then take a carabiner and clip that in, and I'm ready to go. So a wrap 2, pull 1 is rated at approximately 22 kilonewtons when the webbing is new. And I just need to make sure that this angle is less than 90 degrees. We're going to look at a wrap 3, pull 2. So very similar to wrap 2, pull 1, we're going to use 1-inch tubular webbing. We have our anchor post. We're going to wrap around now 3 times instead of 2, and we're going to pull 2 of those strands. So wrap 3, pull 2. So I'm going to start off by tying again that overhand knot, and I'm going to take this, wrap it around my anchor post, and let it dangle. I'm going to then continue around to make 3 wraps. That's 2, and this is my 3rd wrap, making sure that the webbing sits flush all the way around. I'm going to go ahead and finish my water knot, and if you look down in the description below, if you need a review on how to tie an overhand and water knot, there's a link to that particular video. So I've got that tied, and I'm just going to make sure that it looks good and it passes inspection. So I've got at least 4-inch tail on either side, and the knot sits flat and flush. So now what I'm going to do, I've got 3 strands, and I'm going to pull the 2 strands that do not have the knot attached. And you can see that you have to do a little bit of maneuvering to get the knot again in front of the anchor. I've got 2 strands pulled out, and I can go ahead and clip these 2 strands, pull these forward, and this puts the least amount of tension on the knot as possible when it gets pulled. I'm conscientious that this angle is less than 90 degrees. The strength rating of this when pulled is approximately 31 kilonewtons. So if I have a 40 kilonewton rope and I tied a knot in the end of it, reducing it down to about 30 kilonewtons, now they're all approximately the same load rating. All right, now we're going to take a look at a basket hitch. A basket hitch is when we have some webbing. This is 1-inch tubular webbing, and it's already tied into a loop with an appropriate water knot that's been inspected. It's got long enough tails on each side. So what I'm going to do with a basket hitch, I'm going to take the knot and I'm going to pass it around the anchor and then just offset that a little bit so that the knot's not right at my connection point. And then I can simply take my connector, in this case being a carabiner, and put that into place. So that was quick and easy to set up. However, there's a caveat to this. This particular hitch, the way it's designed because of the angles of pull, whereas the other way with wrap 3 pull 2 or wrap 2 pull 1, the strands came around and it just wrapped around this carabiner in one place. This pulls in 2 different directions, so effectively triaxial loading this carabiner, which is not how the carabiner is designed, and it definitely reduces the working load of that carabiner significantly. So if we do this, this basket hitch either needs to be really long so that both of these strands line up on top of each other and are pulled effectively. Like we're talking less than a 40-degree angle, less than a 30-degree angle between these 2 strands. Or we have another device that we can use, which is called a delta or a tri-link. And this goes through these, and it's designed, because of its triangular nature, to be pulled in 3 different directions because the angles are designed as such. So here, you'll notice now I would have to put another connector on, or maybe a bear paw, but now these strands go in line with the spine and with the gate side of this quick link. So that gives me approximately, if I've got 1, 2, 3, 4 strands at 18 kilonewtons, that's 72 kilonewtons of total strength minus a knot, and that knot reduces it by about 40%. So that gives me 35, 36 kilonewtons with good new webbing. Okay. So again, you just have to be conscientious to make this a lot longer if you're going to use a carabiner or use one of our Delta tri-links. So the last one that we have with webbing is called a girth hitch. We do not use this as an anchor. This is not load rated for what we're doing, and I'll show you why. We're going to set this up very similar to how we set up the basket, where I'm going to wrap it around, and then I'm going to take one end and I'm going to pull it through the other loop, and it's going to cinch down onto my anchor post. What this does, this creates a lot of tension right here, no matter where it's placed, and it reduces the load capacity of this webbing beyond what we would ever need for doing a rescue of any sort. So we don't use this. However, we're going to find a spot with the attendants when we're setting up a litter that this is very applicable for using with some of our cord, because it's a precursor to tying a prusik. And there's different avenues, but I just wanted to show you that so that you can see that we have this. This is something that you may see out there, but we don't use it for our anchors. When we're setting up rope system anchors, there are some overarching considerations that we need to take into account. One is the condition of my anchor itself. My system is only as strong as the weakest link in the system, and if this tree is small, if it's got roots that looks like it's rotted, if all of the needles are falling off of the tree or branches look dead, that tells me that this is not in good condition. I have to be considerate of that when putting this all together. The second one is my resources. If I have webbing, then I can go ahead and tie a wrap 2, pull 1, wrap 3, pull 2, maybe make a basket hitch, etc. But I might not have webbing. I might not have extra carabiners. I might not have a lot of rope, so I can't do a tensionless hitch. I have to be considerate of the number of resources that I have. The third one is the purpose. So what is the purpose of this anchor? What am I going to put on it? What are my anticipated loads? I have to take that in consideration. If this was an actual scenario and I had to put 4 people on this, this might not be an appropriate anchor. However, if I've just got one person that's able to walk and I'm just helping to stabilize them, this might be an appropriate anchor. So be aware of your anticipated loads and the purpose of what you're doing with it. The fourth one is your anticipated direction of pull. So if I have a direction of pull that is way off to the left, if this is a nice round anchor, that works great. However, if it's a rock and it's got an undercut on one side, that's ideally where I want the back of my anchor strap to go so it doesn't get pulled up and over that rock. The fifth one is making sure that I have backups and then taking into account failure of something in my system. So for instance, this, if I have this set up, I would have this set up for my main, and I would also have something set up for my belay. So therefore my backup is my belay. In this case, I would have a main and a belay. I wouldn't want to go both off of this particular one. There's ways for me to tie particular anchors if I'm going to connect both my main and my belay to that, which we're not going to cover here. That's something else that we're going to cover in class. My sixth one is that I need to pay attention to my angles that are here. So they need to be less than 90 degrees, ideally less than 60 degrees. At this particular joint. That reduces the amount of force that goes onto each of the strands so that they are in an appropriate level so that we're able to manage those forces. The next one is the height. I have to pay attention to how high this is. So if this is a smaller tree and the tree is only about 10, 12 feet tall, and I pull on this, the tree's going to want to bend over. So my strongest point is as close to the ground as possible. However, when I'm operating a descent control device, an ATC or a clutch or an MPD, I don't necessarily want to be on the ground all of the time. Like, I want to be comfortable when I'm operating, so I need to be considerate of, well, if it's this tall and I have somebody else who's working with me who's only 5'2", that's going to be a rough reach for them to be able to step into my place. So I need to ideally find something around waist height. That's my ideal, but it doesn't always happen, so you need to pay attention to your height that you're tying this. Your last one that I want you to think about is speed of setting up. So if I take maybe something, a pre-tied loop, and I can wrap it around, and I can connect a device to it, that was really fast. However, tying knots around and wrapping a whole bunch of webbing around takes a little bit more time. Just be aware of that. So it depends on what we're looking for. Are we looking for really strong? Are we looking for really fast? Are we looking for something that doesn't utilize a lot of resources? All things to take into consideration. We hope this video was helpful in understanding this component of our rope rescue system. Thank you all for watching the video. Remember to subscribe below to have quick and easy access to all of our videos. We look forward to seeing you in class and out in the field.